Sine and cosine graphs. Objectives: determine amplitude, period, phase shift, and vertical shift of a sine or cosine graph from its equation. Graph variations of y equals cosine x and y equals sine x. Determine a function formula that would have a given sinusoidal graph. A periodic function. A periodic function is a function for which a specific horizontal shift, p, results in a function equal to the original function. F of x plus p equals f of x for all values of x in the domain of f. When this occurs, we call the smallest such horizontal shift with p greater than 0 the period of the function. In the sine and cosine graphs, the shape of the graph repeats after 2 pi, meaning the functions are periodic with a period of 2 pi. The graph of y equals sine x. Let's complete the table of values and sketch the graph between 0 and 2 pi. If x is 0, the sine of 0 is 0. If x is pi over 4, the sine of pi over 4 is square root of 2 over 2. Entering this into the calculator, we see that's about 0.7. The sine of pi over 2 is 1. The sine of 3 pi over 4 is again square root of 2 over 2, or about 0.7. The sine of pi is 0. The sine of 5 pi over 4 is negative square root of 2 over 2, or about negative 0.7. The sine of 3 pi over 2 is negative 1. The sine of 7 pi over 4 is negative square root of 2 over 2, or about negative 0.7, and the sine of 2 pi is 0. Now, we've said that this graph is periodic because these values after 2 pi will just repeat. Here we can graph 0, 0. At pi over 4, I have about 0.7. And at pi over 2, 1. 3 pi over 4, 0.7. Pi, 0. 5 pi over 4, a negative 0.7. 3 pi over 2, a negative 1. 7 pi over 4, a negative 0.7. And 2 pi, 0. If we smoothly connect these points, we can see we have a nice curve, and this will just continue to repeat over here, continue to repeat over here. But between 0 and 2 pi, we see that full period of the graph. Just making some observations here. We see the graph is continuous over its entire domain, and its domain is from negative infinity to infinity. The x-intercepts has x values of the form pi n, where n is an element of the integers. Its period is 2 pi, and the graph is symmetric with respect to the origin, so the function is an odd function. For all x in the domain, sine of negative x equals negative sine of x. We can graph using the 5 key points method. We could sketch these graphs by just using 5 key points, and these are the points associated with the maximums and minimums and zeros of the function. You can divide that period by 4 to get the spacing that is between your 5 key points. The graph of y equals cosine x. Complete the table of values and sketch the graph between 0 and 2 pi. Cosine of 0 is 1. The cosine of pi over 2 is going to be 0. The cosine of pi, -1. The cosine of 3 pi over 2 is 0, and the cosine of 2 pi is 1. Now we have our 5 key points we can graph. 0, 1, pi over 2, 0, pi, -1, 3 pi over 2, 0, and 2 pi, 1. Now it would be quite easy for us to make a graph that looks like this, but just because we have these 5 key points doesn't mean we just connect them in a straight line. We know that there are points in between the points that we graph that cause our graph to make a curve in this type of fashion. So just make sure that when you're graphing this, you don't make straight edges on your graph. Observations about the cosine function. The graph is continuous over its entire domain, and its entire domain is -infinity to +infinity. Its x-intercepts have x values of the form 2n plus 1 times pi over 2, where n is an element of the integers. Its period is 2 pi. The graph is symmetric with respect to the y-axis, so this function is an even function. For all x in the domain, cosine of -x equals cosine of +x. Let's think back about our functions. What are the transformations for y equals -2 times x minus 5 quantity squared plus 4? Remember, the parent graph here is y equals x squared. The transformations that have happened is we have had a shift right of 5 units. We have stretched vertically by a factor of 2, and we also reflected over the x-axis, and we shifted up 4 units. There are similar transformations with the sinusoidal functions. Y equals a sine of b times x minus c plus d, and y equals a cosine of b x minus c plus d. Determining amplitude. A represents the vertical stretch factor, and its absolute value of A, is the amplitude. The amplitude of a periodic function is half the difference between the maximum and minimum values. It describes the height of the graph above and the depth below a horizontal line passing through the middle of the graph. The function is stretched vertically if the absolute value of A is greater than 1, and compressed if the absolute value of A is less than 1. A also determines whether the graph is reflected over the x-axis, as in our previous understanding of reflections. Here we can see our standard y equals sine of x graph in blue. Y equals 2 sine of x is in red, and it shows that every point has the y component multiplied by a factor of 2. The green graph is representing y equals 1/2 sine x, and it's half as tall and half as deep as the standard blue graph y equals sine of x. So the amplitude of the red graph is 2, and the amplitude of the green graph is 1/2. Determine the amplitude of the functions. F of x equals 5/3 sine of x minus 2 plus 7. The amplitude is going to be the absolute value of a, which is 5/3, and the absolute value of 5/3 is 5/3. For g of x, a is -5, so our amplitude is the absolute value of -5, which is 5. And just to be sure, this negative shows that we're also going to have a reflection over the x-axis, in addition to our stretch by a factor of 5 vertically. The local maxima will be a distance of absolute value a above the vertical midline of the graph, which is the line y equals d. In the graph of a above, because d equals 7, the midline has been shifted up 7 units and is now y equals 7. In the graph of b, the midline is the x-axis because d equals 0. Without a horizontal stretch or compression, the period of these graphs is 2 pi. Generally, the period is 2 pi over the absolute value of b. b is going to be that coefficient of x. Observe the modifications of these graph periods. Our standard y equals sine x graph is in blue, and y equals sine of 2x is in red. You can see here that because we have a 2 in front of the x, it has compressed that function horizontally, and we can actually cover 2 complete cycles in that graph by the time that we get to 2 pi. So 1 complete cycle is in just pi. For the green graph, we haven't made a full cycle between 0 and 2 pi. We've only done 1 up and down cycle, but not a down and back cycle. So we have doubled the width of this graph, where the period is now 4 pi instead of 2 pi. Determine the period of the functions. F of x equals sine of pi over 6 times x plus 2. So when I'm looking at this, I know that my period is going to be 2 pi over the absolute value of b. I know 2 pi is then over the absolute value of pi over 6, which is pi over 6. I can multiply this by 6 over 6 to give me 12 pi over pi, which is just 12. The period of that function is 12. Now here I have g of x equals cosine of x over 3. So that we can more clearly see what b is, we can rewrite this as 1/3 x. So my period, p, is equal to 2 pi over the absolute value of b. So that is 2 pi divided by 1/3. Absolute value of 1/3 is 1/3. Now I can multiply by 3 over 3 to simplify this, and I get 6 pi. So 6 pi is the period of that graph. A phase shift is simply a horizontal shift. It's the horizontal displacement of the basic sine or cosine function. It can be found by locating the value c. Observe the phase shifts of these graphs. Here, y equals sine of x. Our basic sine function is in blue. In red, we see y equals sine of x minus pi over 4. And we can see that that has been shifted to the right by pi over 4. And the green graph, y equals sine of x plus pi over 4, has been shifted to the left by pi over 4 units. What is the phase shift of the sinusoidal function? So let's practice this. We can see here, this is our A, B is 1, and C is pi over 4. So the phase shift here is pi over 4, and that means pi over 4 shifted to the right. When I'm looking at f of x equals 1/2 sine of 3x plus pi over 5, we have to do a little bit of work. It's not necessarily in the right form. F of x is equal to 1/2, that's our A, sine of 3, that's our B, x plus pi over 5 divided by 3 is pi over 15. If you want, you can put square brackets around that. But this is our C. If you look back at standard form, the B is factored out of all of the argument for sine. So this means that we are shifting left. The phase shift is negative pi over 15. So that means that we're going to shift left by pi over 15. The negative denotes we are shifting left. While C relates to the horizontal shift, D indicates the vertical shift from the midline in the general formula for a sinusoidal function. Y equals D is the midline of a vertically shifted sinusoidal curve. Determine the vertical shift for the sinusoidal curve. Here I have f of x equals 3 cosine of x minus pi over 2, and then I have minus 2. This means that we are shifting down 2 units. And here I have f of x equals 5 sine x. Then I'm adding on 2. This means I'm going to be shifting up by 2 units. Putting it all together, given the general forms of sinusoidal functions, y equals a sine of b times x minus c plus d, and y equals a cosine b x minus c plus d. The transformations can be summarized by the information in the table. Note that the phase shift plus the period will give you the ending point of one full cycle of your graph. That phase shift is going to be the first point of one full cycle. Amplitude is the absolute value of A. Period is 2 pi over the absolute value of B. Phase shift is C, and vertical shift is D. Describe the transformations of the following functions from their parent graph. Here, y equals 1/2 cosine of x over 3 minus pi over 3. It might be a good idea for you to rewrite this. If you don't see it right away, this is 1/2 cosine of 1/3 x minus pi over 3. So let's go ahead and factor out the 1/3. It's 1/3 x minus pi. If we would redistribute the 1/3, we would come up with x over 3 minus pi over 3. Now my amplitude is the absolute value of a, which is going to be a positive 1/2. The period is 2 pi over the absolute value of b. b is 1/3. And remember, we want to multiply by 3 over 3 to simplify that, and it makes it a period of 6 pi. The phase shift, remember, we want to look at it in this form. The phase shift is going to be right by a value of pi. The vertical shift, we don't have anything added on over here, so plus 0. We have no vertical shift. And is there some kind of reflection over the x-axis, or if there's a vertical shift, some reflection over that midline? No. If we did, we would have a negative sitting out front here. So there's no reflection. For the next one, y equals 3 sine of 2x plus 1. No need to rewrite anything. The amplitude is 3. The period is 2 pi over the absolute value of b, which is 2. We simplify that. The period is pi. There is no phase shift. And the vertical shift is up 1. And there is no reflection. F of x equals sine of pi x plus 3. My amplitude is 1. The period is 2 pi over b, which is pi. That simplifies to be 2. One thing that tells us is that my horizontal axis is going to be labeled with integers rather than some denomination of pi. The phase shift, we have none. The vertical shift, we're going to be going up 3 units. And there's no negative in front of the sign, so there is no reflection. For amplitude, on part D here, we have a negative 2 in front, which we take the absolute value of, so the amplitude is 2. The period is 2 pi over 1, which is just 2 pi. The phase shift is a negative 3 pi over 4, which means the negative indicates we're going to be moving to the left by 3 pi over 4. There is no vertical shift, and there is a reflection. We'll have to reflect this vertically. State the transformations of the functions and make a sketch of the graph. Label your axes appropriately and make sure to draw in your y-axis at the appropriate place. First, we want to rewrite the function. F of x equals 2 sine of 2 times x minus pi over 3, just factoring out b, plus 6. So I know my amplitude is sitting right here of 2. The period is 2 pi divided by b. b is this 2. So 2 pi divided by 2 is pi. The phase shift is a positive pi over 3. Vertical shift, we're going to move the graph up 6 units. And we don't have a reflection. So let's start here. Our phase shift, pi over 3, is going to be the first point in this one period of the graph that we will draw. Now, what is the end point? The end point is going to be that phase shift plus the period, and that ends up being 4 pi over 3. So here's 4 pi over 3. Now, one thing that we can do to find this middle between them is treat it as an average. We can add pi over 3 plus 4 pi over 3 is 5 pi over 3, and then divide it by 2, or multiply it by a half. So 5 pi over 3 times 1/2 is 5 pi over 6. Then, to get those points in between, we'll add these two and divide by 2. We'll add these two and divide by 2. So let's try here first. First, let's get a common denominator. This is a 2 pi over 6. So if I take 2 pi over 6 and I add 5 pi over 6, that's 7 pi over 6. And half of 7 pi over 6 is 7 pi over 12. Next, to find this one, 5 pi over 6 plus 8 pi over 6 is 13 pi over 6. And half of 13 pi over 6 is 13 pi over 12. So we have our x places for the 5 key points. Let's go ahead and get our y-axis set where it's supposed to be. Now this is pi over 3 right here, and this is 7 pi over 12. So what are those as both 12ths? This is 4 pi over 12. And this is 7 pi over 12. So if we have 3 pi over 12 between there, then we have 4 pi over 12 between this pi over 3 and the y-axis. So it's going to be just a little bit further than being equidistant. So I'm going to scooch this over a little bit right here. And that's going to be where my y-axis sits. Here we are. And let's set our amplitude here. This is 1. This is 2. This is 1 down here and a -2. And I know with a sine graph, I start with the x-intercept. So I'm starting on the midline. And then the next key point is going to be the high. The next key point will be on the midline. The next key point will be on the minimum. And the last key point will be on the midline again. And then just smoothly connect those points. Make sure that you try to make it into a curve that looks somewhat sinusoidal, and just do your best there. F of x equals -3 times the cosine of pi over 2x. My amplitude is the absolute value of -3, so +3. The period is 2 pi over b, which is pi over 2. And if I can go ahead and simplify that, I'll multiply by 2 over 2. That gives me 4 pi over pi. which is 4. There is no phase shift. There's no vertical shift. And there is a reflection over that midline. So I'm going to go ahead and put my y-axis here. There's no phase shift, so this is easy to set. And I'm ending over here at 4. Okay. And I can break this up then into equal parts. 1, 2, 3, and 4 we have. Amplitude is 3. So I'm going to have a height of 3 and a depth of -3 there. And then I go ahead and start with my points. Now remember, we do have a reflection. Normally, cosine would start on its maximum, but we're going to be starting with a minimum instead because it's been reflected over its horizontal midline. So here I have these points. And remember, don't make a straight line. Make this a sinusoidal curve. And just do your best. Might have to erase and try again. There you go. That's one full period of that function. In this example, f of x equals 1/2 sine of pi over 4x minus 1. My amplitude is going to be the absolute value of a, so a positive 1/2. The period is 2 pi over the absolute value of b, so that's pi over 4. If we multiply by 4 over 4, we get 8 pi over pi, which is 8. The phase shift, we will have no phase shift, and the vertical shift is down 1 unit. There is no reflection. We don't have a negative in front of the a. So now we can go ahead and start with graphing. This won't be too hard because we're starting at the x value of 0. My period is 8. So we cut that in half and we get 4. Cut that in half, we get 2. And the number between those, so there's 6. The amplitude is 1/2, so let's go ahead and label that. I've got a -1/2 here and -1. And I know with the sine graph that I have to start at the midline. The next point is going to be the max. The next point, I'm back at the midline. The next point, I'm at the minimum. And the next point, I'm back at the midline. And again, we make this as smoothly curved as we can. And that gets us one period of that function. And we have here a cosine function already graphed for us. We want to see if we can determine what the formula for that is. So we're going to work backwards from what we've done before. So let's start with amplitude. Amplitude. Well, my lowest is down here and the highest is up here. That is a total of 8. So halfway is going to be an amplitude of 4. So the absolute value of A is 4. But in looking at this, I can see that we've started at a low. Midway through a cycle, we're at the high, and ended the cycle with a low. So this function has been reflected around its midline being here. So we do have an A value of -4. Okay, that still gives us an amplitude of 4, but it gives us the reflection that we need to start at a minimum and end at a minimum. The period, let's see, we start here at 0 and we've ended at 14. So the period is 14. Now we can use that information. We know 14 is what my 2 pi over b is. So if I would solve this, I get 14b equals 2 pi. Divide both sides by 14, and this is going to give me a b value of pi over 7. So my next thing to find is the phase shift, and we're going to say there is none because we're starting right here at the x-axis. And the vertical shift, we did shift up 2 units to get to that midline. So D is a positive 2. So let's put this together. We have y equals a times cosine of b x minus c plus d. So y is a of -4 cosine of b, which is pi over 7, x, the c was nothing, we don't have a phase shift, so I can just close that here, and d is a positive 2. So that is the formula that could give us that graph. It's not the only formula, but this is a good one that we could use. And similarly, for this one, let's determine a formula for this function graph below. Now, they did not give us a hint on this, whether it is a sine or a cosine, so you can decide which function you want it to be. It could be either one, depending on if you're going to shift it one way or another. I'm going to go ahead and say that this is a sine function because I'm starting at the midline and ending at the midline. So I'm going to take this as being a sine function. The amplitude is 2, and there is no reflection. We started at the midline and went up from there. So that's just the standard sine function. So this means that my a is a positive 2. The period, looks like the period is over at 4. So 4 is that value of 2 pi over b. This means 4b equals 2 pi. And I divide both sides by 4. This means my b is pi over 2. We don't have a phase shift and we don't have a vertical shift. So quite simply, our formula is y equals 2 sine of pi over 2 x.